Swayam Prabha. Digital India. Educated India.
Okay. So, just for the sake of completeness, what we'll look at today is power effects on directional stability. Actually, it's not so much, at least in the textbook available, you don't find much of mention of this part. So, even though we have some information available in the book by Phillips and in Perkins and Hayes, other than that most other textbook will talk about the difficulties involved in finding contribution of indirect effects of propeller on delta Cn beta and Cl beta, right. So, direct effects are coming from the direct forces which are being generated at the propeller disc, right. An indirect effect is due to so indirect effect is due to propeller slipstream. So, let us say the propeller is rotating, right, and there is a unbalanced force because of this propeller which is in the negative y direction, right. And it's this force can be because of this side slip angle, right. So, which way is going to create a moment? Negative yaw moment, right. So, delta Cn beta contribution in this case is for positive beta you are getting a negative yaw moment, right. So, this is a destabilizing effect. Again, to quantify which way this force will be acting, right. So, someone has to verify that, right, before you can comment on this part, before you comment on the directional stability. Okay. What happens if this propeller, now this is a, what kind of arrangement it is? It is a tractor arrangement, right. You are pulling the aircraft, the aircraft where you have pusher engines. So, in those cases, so now this gives me a positive yawing moment, right, for positive side slip. So, pusher type arrangement right. So, this is giving me a stabilizing effect, right, in directional motion. Is this clear? Is this clear? What else? These are direct effects, right, because of the forces being created at the propeller disc, right. Indirect effect is due to the propeller slipstream. So, how propeller slipstream is going to affect the flow behind, right, that is what is going to also add to this delta C and beta, right. And we said if the flow is coming at a side slip angle beta, look at what is happening because of this particular arrangement. So, flow is affecting this part of the wing, right, and because of which there will be an increase in what, the drag on this part. Okay. So, delta D, which will be increased because of this propeller slipstream, right. So, you know that you are going to have a yawing moment because of this increase in drag, right. So, So, delta C and beta contribution indirect positive side slip is going to give you a negative yawing moment, right. Yeah. When we have a tractor type arrangement, right, because of this side slip beta, there will be a unbalanced force, right, in the xy plane, which will create a moment about the CG, yawing moment, right, and that yawing moment is what? Negative, right, because it's rotating like this. So, your y is moving towards x axis, right, that is when we say that it is a negative yawing moment, right. So, delta C and beta is going to be less than 0, right. For positive side slip you are having a negative yawing moment, and that is a destabilizing effect, right. For the same now you can argue in the same manner, and you can say that the pusher kind of arrangement can result in, for positive side slip, can result in positive yawing moment, right, and that is a stabilizing effect, right. C and beta should be greater than 0 for stability in yaw. Yeah. Okay. And third case is this, when propeller slip stream is affecting the flow over the wing, right, and that is going to create additional drag on this part of the wing, and that is going to give you a negative moment, right. Okay. Now, let us, so we are more or less done with this part. Okay. The only thing remaining is now the control in, we also looked at the directional control, right. So, one control which is left is now the control in roll, right. Right. So, you know that to initiate a roll motion or to control a roll motion, you have to create differential lift over the two sides of the wing, right. Right. Which control is used for, which control surface can give you this? Aileron, right? Anything else? Aileron and spoilers, right? Right. So, let us look at look at how they look like. Okay. A spoiler is a flap which is on the top surface of the wing, right. It is mainly used for creating drag. So, it will be somewhere right. So, if you do not want to create drag, but you only want to change the or initiate a roll, you just deflect one of the spoilers, right. It cannot go down, right, it can only move up. It is on the top surface of the wing. So, you can deflect one of the spoilers, right, and that is going to change the lift. So, differential lift is created even though the other is in the neutral position, is not it. So, main control for roll is aileron, right, we know that much. And where should it be located on the wing? Towards the tip, right, because we want a larger arm length. So, it will be located somewhere here. Right, and now I can change the camber of the wing by deflecting aileron, right, at these locations, right, in this part, so that I can create a or I can change the lift, right, by some amount, so that I can get roll. Now, convention is that, right, like what we have been seeing for Cn delta or Cm delta E. The control power is having a negative sign, right, Cm delta is negative and Cn delta is also negative. So, a positive aileron deflection should give me a negative rolling moment, right. So, what should be aileron deflection up on the, what should be the sign of this aileron deflection? So, if you want a larger roll, you can simultaneously deploy both sides, right. So, this will go up, this will go down, is not it. You cannot have both of them up, because that is not going to give you a differential lift. Okay. So, this, let us say I deflected aileron up, right, what rolling moment is going to give me, and that side is, let us say, down. Okay. Let us say both by same amount, right. So, this one is going to give you a change in positive change in angle of attack at these sections on the wing, right. So, correspondingly increase in the lift, right, and this is up deflection is going to decrease the lift, right. And what is the sign of the rolling moment because of this? Lift is more here, right. So, what will happen? Z will move towards y, right, z axis will move towards y axis, is not it. What kind of roll that is negative, right. So, in this particular arrangement, when on this part of the wing because of this we get a negative rolling moment. So, there is a positive arrangement of aileron deflection, right, which is giving me a negative rolling moment, and let us try to find out an expression for this derivative. Or change in rolling moment coefficient with respect to change in aileron deflection, right. CL is the rolling moment coefficient. So, let us try to find out an expression for this parameter. We can also call this as aileron control power, is not it. So, there is a wing which is swept back, the wing is also having a taper, right. So, this chord the root is CR, root chord length is CR, and tip chord is CT, right, and aileron is at a distance y1 from the center line and is having a length which is y2 minus y1, right, and span of the so half span of the wing is b over 2, right. The chord length, right, of this particular section of the airfoil section which is at a distance y from the center line is Cy, right. It is going to vary because there is a taper. The wing gets tapered. So, you can write down an expression for the taper ratio, which is Ct over Cr, right. What is Cy? We can find an expression for Cy, right, in terms of Ct and Cr and taper ratio. Right. Chord length at y, right, minus root chord which is at y equal to 0, right, Ct which is at b over 2 minus Cr which is at 0, right. So, what is Cy? Now, I want to find out what is the change in lift when I deflect aileron at this section, right. So, I want to find out change in lift okay. Change in lift due to aileron deflection at wing section at a distance y from the center line, right. What is that? Dynamic pressure into the area, right. What is that area here? The chord length into this thickness, right. And Cl alpha of the wing into delta alpha, right. And this delta alpha is because of the aileron deflection, right. So, you can write this delta alpha as and this Cl alpha is Cl alpha of the wing. So, I can also write this as AW. What is this quantity? It's like aileron effectiveness parameter, isn't it? And it will depend upon the surface area of the or area of the aileron, right, as compared to the area of the wing, right. So, you can use actually the same plot which we saw for elevator effectiveness parameter, it is actually the same, right. Aileron effectiveness parameter. Yeah, into Cy, right. Now, the moment because of this is going to be so they change I have deflected the aileron down, right. So, it is going to give me a positive roll, right. So, sign of that aileron deflection should be negative because we have to maintain a uniform convention, right. So, all control derivatives will have negative sign. So, that aileron deflection which is going down on the on this part of the wing should be taken as negative, right. Okay. That is clear. Now, we need to find out what is the roll moment created because of the change in lift over this whole part, isn't it. So, I have been writing L prime for the rolling moment coefficient. So, actually you can find out what is L prime y, right, because of the lift at location y, and you can probably put a delta sign here. Right. So, remember this aileron deflection is negative. You have to keep that in mind. I can also probably put a negative sign somewhere, so that finally CL delta is negative. Okay, let me carry on this and then we can finally do that. Okay, so this is a rolling moment, total rolling moment because of the aileron deflection, right. So, I am deflecting aileron on both the sides, right. So, it will have twice of that effect, isn't it. So, one wing is going up, as one aileron is going up, other one is going down, and both of them are adding to the rolling moment, right. So, it is twice that effect, right. And between y1 and y2, right. am writing an expression for this Cy now. Right. Now, I have to non-dimensionalize everything, right, because I want to find out change in rolling moment coefficient because of the aileron deflection, right, and that has to be done with respect to the wing, right. So, Q S of the wing, right, into span into CL, right. So, that your CL delta A, which is so this also has to be a negative sign. So, I can actually use this this delta A is negative, right, and aileron up is also negative on the other side, that is what is going to give me this CL. So, you can put a negative sign here, right. Is this clear? We want to solve some problems now, which I will do in the next class. We will try to take up some problem and try to find out rudder requirement or the aileron requirement in different situations. Okay. We will solve some problems in the next class.